Hi everybody, welcome to the second video in our 14-day introduction to satellite Earth observation. In our first video, if you recall, we loaded up a Sentinel-2 dataset and we added it to the map on an area of interest that was over Manhattan. We chose Manhattan because we could see a bit of the urban area, we've got a bit of water here, and we've got some of Central Park. And you'll see that Central Park has various colours in here. These yellow dots, for example, are the baseball diamonds, and there's a brighter green area in the grassland. The vegetation is all quite dark because, in fact, vegetation, the trees, will absorb quite a lot of light. That's part of what they do with photosynthesis. Now, I want to look in this lesson in a little bit more detail about how this colour picture is created. In the next lesson, we're going to look a little bit more of the colours that are beyond the visible part of the spectrum, and some of the more scientific data that we can collect with instruments like Sentinel-2. But first of all, let's look at what we're actually viewing here. Now, as I mentioned in the first video, this block brings in the Sentinel-2 data. We've got an area a block that chooses the area that we're looking at. This block determines the time period, and so I've now chosen this to just be the last couple of months, June to August. This block gets rid of the clouds. This block squashes all the data into one image. So there's multiple collections of the image, but this is going to just squash it into one image. But in this lesson, we're going to focus on this block, the Add Map Layer block. And it says true color here. And it's also got an option for multiple bands or selecting a single band. And what we mean by a band is the different sensors in the instrument that collect at different wavelengths. So there's a sensor that's collecting in red, there's a sensor collecting green light, there's a sensor collecting blue light. In the next lesson, we'll see how it collects in the near infrared as well and beyond. So what we choose to create this color image is that we've selected the red channel for the image to come from the red band. The green channel, which is the G here, is the green band, and the B is the blue band. So we've got a matching set of red to red, green to green, blue to blue. And the way this builds up a color image is because each of these channels is detecting something slightly different. So for example, if we look at a single channel now and we only look at the blue, if we run this, what we'll get is a black and white image now because it's only one channel. It's just scales of grey. And we'll see that the urban area is quite light, so it's lots of light greys and whites. But Central Park and the grassland and all the trees is very much darker now. And we would think that maybe we would expect there to be a bit more green light. So if we duplicate this Add Map Layer block and add it in here, and for this one we're going to choose green, and you'll notice that Earth Blox tries to keep up and default things to sensible values. So the layer name is now automatically changed to green because we've chosen green. And when we run this, it will now give the labels on the layers box these labels that we've got in the Add Map Layer blocks. So this now runs and creates a green layer and a blue layer. The green layer, if I switch that on and off, is mostly the same over the urban areas, but in the fields and vegetation in Central Park, it's actually slightly brighter in the green. Not much, because there's still not a lot of light. A lot of the radiation is being absorbed for photosynthesis, remember? So even the green is actually not very bright, but there's more green than there is blue. And that means that when we combine them together, I'll put this one into the bin, when we combine them together so that red is in the red channel, green is in the green channel, blue is in the blue channel, is that because there's a brighter signal in the green channel than there is in the red or the blue channel, it comes out greener, a slightly green tone. This is going to be the basis of how we visualize a lot of the data, either as single bands or as three bands together into a color image. So it's important that you get the hang of that. So try that with the other areas that you looked at. And in the next lesson, we're going to go beyond the red, green and blue, and we're going to go into the near infrared and look at some of the other wavelengths that are available from the Sentinel-2 data.